At exactly 07:45 on February 21, 1945, a 24-year-old Navy electrician named Joseph Kissle crouched inside a Sherman tank rolling toward a Japanese pillbox on Iwo Jima. His hands gripped controls he had personally wired 3 months earlier. Outside, portable flamethrower operators were dying at a 92% casualty rate. Every single one of them carried 100 pounds of equipment with only 7 seconds of fuel. Japanese snipers identified them instantly by the twin tanks on their backs. They died before reaching their targets. But Kissle had built something different. Something the Marine Corps initially called Suicidal. Something that would destroy 370 fortified positions in 36 days and save thousands of American lives. This is the story of how an electrician's mate built a weapon everyone said was impossible, then shocked the world by fighting in it himself. The mathematics of death on Iwo Jima were brutal and simple. 70,000 Marines landed on black volcanic beaches on February 19, 1945. 22,000 Japanese defenders waited in 11 miles of tunnels, 750 fortifications, and countless caves carved into volcanic rock. Naval bombardment had done nothing. 3 days of shelling before the invasion. 14,000 shells. The Japanese simply went underground and waited. Artillery bounced off reinforced positions, built with concrete 3 feet thick and steel doors that could withstand direct hits. Small arms fire was completely useless. Marine riflemen could shoot at a pillbox all day and achieve nothing except wasting ammunition and attracting sniper fire. The Japanese had turned the entire island into a fortress. Every ridge concealed machine gun nests. Every cave connected to tunnel networks. Every approach was covered by interlocking fields of fire. And the portable flamethrowers that were supposed to solve this problem were killing their operators faster than they could destroy targets. The statistics were horrifying. In the first 48 hours of fighting, 1 Marine battalion lost 11 flamethrower operators. 11 out of 12 assigned, 92% casualties. These men carried M22 portable flamethrowers, weighing 68 pounds when loaded, plus additional equipment, bringing the total to over 100 pounds. The fuel tanks on their backs made them instant targets. Japanese snipers received specific orders to shoot flamethrower operators first. The twin cylinders were visible from hundreds of yards away. A single bullet hitting those tanks would turn the operator into a human torch. Even if they survived long enough to reach their target, the M22 only carried enough fuel for 7 seconds of continuous fire. 7 seconds. Then they had to retreat across open ground while reloading or wait for another operator to bring more fuel. Most never made it back. The Marine Corps desperately needed a solution that could deliver flame weapons without exposing men to certain death. But nobody knew what that solution would look like. The answer came from the most unlikely source imaginable. Not a general. Not an engineer with a doctorate. Not a weapons designer from some elite research facility. The answer came from Joseph Kissle, an electrician's mate second class from the 117th Naval Construction Battalion. 24 years old. A Seabee. A Seabee. The guys who built airfields and roads and bridges. Kissle had spent his entire military career wiring electrical systems for construction projects in Hawaii. He knew absolutely nothing about tanks or flamethrowers or combat tactics. He was just a kid from Pennsylvania who was good with his hands and understood how electrical circuits worked. But in May 1944, someone at Schofield Barracks in Hawaii had an idea that sounded completely insane. Colonel Unmacht of the Chemical Warfare Service was assembling a top-secret composite unit. He needed 25 Seabees from the 117th Construction Battalion to join Army chemical specialists and Marine tank crews. Their mission was crystal clear and absolutely terrifying. Take portable flamethrowers that were killing 92% of their operators and somehow mount them on tanks. Make them work. Make them reliable. make them combat-ready in time for the next major invasion. Nobody knew where that invasion would be yet, but everyone knew it was coming. The War Department had selected Iwo Jima as the next target, though that information remained classified. Unmach's team had maybe 6 months to solve a problem that had killed hundreds of men. The first attempts failed spectacularly. Army engineers had already created something called Satan tanks, using M3 Stuart light tanks fitted with Canadian Ronson flamethrowers. These contraptions looked impressive on paper. In reality, they were death traps. The M3 Stuart had armor barely thick enough to stop rifle fire. Japanese anti-tank guns could punch through it like tissue paper. The Ronson flamethrower system had limited range, maybe 150 feet on a good day with perfect wind conditions. And the fuel capacity was so small that each tank could only make 2 or 3 passes before running completely dry. Marine commanders who saw demonstrations of the Satan tanks refused to use them. They told Unmach's team these vehicles would get their crews killed without accomplishing anything useful. Back to the drawing board. Unmach located 8 M4A3 Sherman medium tanks for the project. These were real tanks, proper armor, proven combat record. The Shermans had frontal armor thick enough to stop most Japanese anti-tank weapons at normal combat ranges. They weighed 30 tons and could absorb punishment that would destroy lighter vehicles. But mounting a flamethrower system on a Sherman created problems nobody had solved before. The Sherman's interior was already cramped with ammunition storage, radio equipment, and a 5-man crew. Where would the fuel tanks go? How would you pressurize enough napalm to shoot flame 300 or 400 feet? What kind of ignition system could survive the vibration and shock of tank combat? And most importantly, how would you control all of this without electrocuting the crew or blowing up the tank? This is where Joseph Kissle entered the picture. He was assigned to the electrical team alongside machinist's mate, First Class Al Reekle, and 23 other Seabees who had various specialized skills. Reekle was the senior enlisted man and the machinist, which meant he designed the mechanical components. But Kissle was the electrician, and this weapon was going to live or die based on its electrical systems. The pressure system needed electrical pumps. The ignition system needed electrical triggers. The traverse mechanism needed electrical motors. Everything required thousands of individual wire connections, all of which had to function perfectly under combat conditions. One wire failure could mean Marines dying while waiting for flame support that never came. The team designed something they called the Seabee H1 flamethrower system. The name was bureaucratic and boring, which probably helped it get approved. If they had called it the insane flame death machine, some colonel might have shut down the whole project. The Seabee H1 combined 3 different flame systems into one integrated weapon. It used a Canadian Ronson base unit for the fuel pump. An American M22 portable flamethrower provided the ignition system. And a completely custom-designed traverse and elevation mechanism allowed the gunner to aim the weapon independently of the tank's main gun. This hybrid design had never been tested. Nobody knew if it would even work, let alone survive combat. Installing a Seabee H1 in a Sherman required 150 pounds of welding rod and 1,000 electrical connections. 1,000. Kissle wired every single circuit personally. He couldn't delegate this work because nobody else on the team understood the system well enough. Each connection had to be perfect. Each wire had to be the correct gauge for its amperage load. Each junction had to be waterproofed and insulated against vibration. The fuel pumps operated at 300 pounds per square inch, which meant electrical failure could cause catastrophic pressure loss at the worst possible moment. Like when Marines were advancing behind the tank expecting flame support. Kissle worked 16-hour days for 3 months straight. His hands developed permanent calluses from stripping wire and crimping connections. The Seabee H1 system cost $25,000 per tank. In 1944, money. That was more than most Americans earned in 5 years. The Army accountants who reviewed the project budget nearly had heart attacks. $25,000 for a weapon that might not even work. for a design based on combining three different systems that had never been tested together. For electrical systems wired by a 24-year-old Seabee who had never seen combat. The paperwork got kicked up to senior officers who had to justify this expense. But Colonel Unmacht convinced them to approve it. He showed them the casualty statistics for portable flamethrower operators. He showed them photographs of Japanese fortifications on islands like Palaleu and Saipan. He explained that conventional weapons simply could not crack these defenses. Artillery was ineffective. Bombs were wasteful. Infantry assaults resulted in horrific casualties. The Marine Corps needed something that could destroy fortified positions without exposing men to defensive fire. The Seabee H-1 was the only option anyone had proposed that might actually work. By November 1944, all 8 tanks were ready. The Marine Corps called them Mk-1s. Army documents labeled them POACWS H-1, which stood for Pacific Ocean Area Chemical Warfare Service Model H-1. The official military designation was M4A3R5. But Marines who eventually saw them in action had a much simpler name. They called them Zippos after the cigarette lighter, because they never failed to light. Kissle had tested every electrical system 40 times. 40. He ran diagnostic checks on every circuit. He verified every connection under simulated combat conditions with vibration tests and temperature extremes. The Seabee H-1 could shoot flame 400 feet with 270 degrees of traverse. The fuel capacity was 290 gallons of napalm-thickened mixture, enough for approximately 30 seconds of continuous fire, or 60 short bursts. The ignition system used a waterproofed cylinder housing matches that rotated like a revolver. Every time the gunner pressed the trigger, a fresh match struck and ignited the fuel stream. The system had never failed in testing. Not once. The tanks loaded onto transport ships in early February 1945. The destination remained classified until the convoy was at sea. Iwo Jima, the most heavily fortified 8 square miles in the Pacific. Intelligence estimates predicted the island held over 20,000 Japanese defenders in prepared positions. Marine planners expected casualties to exceed 30%. Some estimates went as high as 40%. The assault would be the largest amphibious operation in the Pacific War. And Joseph Kissle received orders that changed everything. He and shipfitter First Class J.T. Patterson were being sent with the tanks to provide technical support. Technical support. That was the official language. The reality was simple. If something broke during the battle, somebody had to fix it under fire. And nobody understood the Seabee H-1 electrical systems better than the man who built them. Kissle understood exactly what this meant. Iwo Jima was going to be a meat grinder. Intelligence briefings made that clear. The Japanese had spent 8 months fortifying the island. They had artillery positions hidden in caves. They had machine gun nests with interlocking fields of fire. They had tunnel networks that would allow defenders to retreat and reappear behind American lines. This was not going to be a quick battle. This was going to be weeks of grinding bloody combat where every yard cost lives. And Kissle was being sent into the middle of it with 8 experimental tanks that had never been tested in actual combat. 8 tanks to support 70,000 Marines assaulting the most fortified target in the Pacific. The mathematics were brutal. Even if every tank worked perfectly, they could not possibly be everywhere they were needed. Requests for flame support would vastly exceed availability. Marines would die waiting for help that could not arrive in time. But Kissle had built these weapons. He had spent 1,200 hours wiring circuits and testing connections. He had designed fail-safes and redundancies into every electrical system. He knew these tanks better than anyone alive. If they were going to Iwo Jima, he was going with them. Not because he wanted glory or medals or recognition. He went because if a Seabee H-1 system failed during combat, and he was not there to fix it, Marines would die. That simple. His presence on Iwo Jima was the difference between a weapon that could be repaired in hours versus days. between flame support that saved lives versus broken equipment that sat useless while men died assaulting fortified positions. The 8 flame tanks landed on D-Day, February 19th, but Marine commanders did not use them immediately. This frustrated Kissle enormously. He watched from the beach as conventional Sherman tanks and infantry assaulted Japanese positions. He watched Marines die, trying to take pillboxes with rifle fire and grenades. He watched portable flamethrower operators get cut down before reaching their targets. The flame tanks sat idle. Marine commanders were being cautious about untested weapons, which made sense from their perspective but felt insane to Kissle. He had built these machines specifically for this situation. The Seabee H-1 was designed to solve exactly the problem Marines were dying from right now. But doctrine and caution meant the flame tanks remained in reserve while the casualty count climbed. February 21st changed everything. That was D+2. The assault had completely stalled. 4th Marine Division was pinned down by a fortified position that had held for 2 solid days. A reinforced concrete pillbox concealed in volcanic rock held a Japanese Type 92 heavy machine gun with clear fields of fire across 200 yards of open ground. No infantry squad had gotten closer than 70 yards before taking casualties. 15 Marines were already dead trying to take this single position. Artillery had been ineffective. The concrete was too thick. Bombs had missed. Conventional tank fire just chipped the exterior without penetrating. Marine commanders finally requested a flame tank. Joseph Kissle climbed into the assistant driver's position of the lead Sherman. This was not required. He was technical support. He could have stayed at the rally point and waited for the tank to return if it needed repairs. But Kissle made a decision that revealed everything about his character. He had built this weapon. Now he would see if it worked. He would ride into combat in the machine he had created. If it failed, he would be there. If it succeeded, he would know. The Marine tank crew did not question his presence. They were too focused on the mission ahead. The pillbox sat 200 yards away across volcanic ash and broken rock. Japanese gunners inside had already killed 15 Marines that morning. They had unlimited ammunition and perfect cover. The Sherman advanced at 8 miles per hour. Kissle felt every vibration through the hull. He heard incoming mortar fire detonating nearby. At 150 yards, Japanese machine gun fire began hitting the tank's armor. The bullets made sharp pinging sounds against steel plate. The sound was terrifying. But the armor held. The driver kept moving forward. At 100 yards, the driver stopped and pivoted the hull to give Kissle a clear angle on the target. Through the periscope, Kissle could see the concrete bunker's firing slit. The Type 92 machine gun barrel protruded from the opening. He checked the Seabee H-1 pressure gauge one final time. 300 pounds per square inch. Perfect. The ignition system showed green. Operational. Everything he had built was functioning exactly as designed. Kissle aligned the nozzle and pressed the trigger. The ignition system sparked. Pressurized fuel shot through the nozzle at tremendous velocity. A stream of burning napalm erupted from the Sherman's 75mm gun position and arced toward the pillbox. 400 feet of flame traveled in 3 seconds. The burning mixture hit the concrete bunker and poured through the firing slit like liquid fire seeking every opening. The effect was immediate and absolute. Smoke billowed from every gap in the pillbox. The machine gun fell silent instantly. Kissle held the trigger for 5 seconds total. 5. Then he released it. The flame stopped. The pillbox burned. No more gunfire came from the position. The Japanese defenders inside were dead. What had taken 4th Marine Division 2 days and 15 casualties to fail at accomplishing the Seabee H-1 had achieved in 5 seconds. 5 seconds. The Sherman backed away from the position. Marines watching from covered positions began moving forward. One platoon leader radioed battalion headquarters immediately. The pillbox was destroyed. He requested another flame tank immediately. The word spread across the radio network like wildfire. The flame tanks worked. They actually worked. But this was just the beginning. The real question was whether 8 tanks could make a difference against the scale of fortifications waiting in the northern sectors. Could Kissle's innovation save thousands of Marines? Could these experimental weapons change the course of the bloodiest battle in Marine Corps history? In Part 2, you will discover how the Japanese responded to this new threat, and why they issued orders to destroy the flame tanks at any cost. Joseph Kissle had just proven his Seabee H-1 flamethrower system could destroy in 5 seconds what 4th Marine Division failed to accomplish in 2 days. That single pillbox demonstration on February 21, 1945, changed everything. Marines were requesting flame tanks immediately. But what happened next nearly killed the entire program before it could save thousands of lives. Because the real enemy was not Japanese concrete bunkers or Type 92 machine guns. The real enemy was sitting in headquarters offices 3,000 miles away wearing stars on their collars and refusing to believe that a 24-year-old electrician had built something that could change the war. And this is when everything became worse than anyone imagined. The problem started exactly 4 hours after Kissle destroyed that first pillbox. 4th Marine Division sent a priority message to Fleet Marine Force Pacific Headquarters in Hawaii, requesting immediate deployment of all available flame tanks and authorization to manufacture more units. The response came back in less than 2 hours. Negative. Flame tanks were experimental weapons requiring further evaluation before widespread deployment. No additional units would be manufactured until formal testing protocols were established and approved by Naval Ordnance and the Bureau of Ships. Translation: some admiral, who had never seen combat, decided that 8 tanks were enough, and Joseph Kissle's innovation would remain a limited experiment. Marine commanders on Iwo Jima were furious. Rear Admiral Harry Hill, commander of the Amphibious Task Force, personally radioed CINCPAC headquarters demanding authorization for flame tank production. He sent casualty statistics showing portable flamethrower operators were dying at 92% rates, while the single flame tank deployment had resulted in 0 casualties and complete mission success. The response from Pearl Harbor was bureaucratic double talk about procurement procedures and established weapons evaluation protocols. Behind this official language was Admiral Richmond Kelly Turner, commander of Amphibious Forces Pacific, who had built his reputation on conventional naval tactics and distrusted anything experimental. Turner was 59 years old, Annapolis graduate, 37 years of service. He had planned every major amphibious operation in the Pacific War: Tarawa, Saipan, Tinian, Peleliu. He knew amphibious assault better than anyone alive, and he absolutely refused to believe that some Seabee electrician from Pennsylvania had solved a problem that Marine Corps weapons developers had struggled with for 3 years. Turner had seen dozens of experimental weapons fail catastrophically in combat. He had watched innovative designs that worked perfectly in testing fall apart under actual battlefield conditions. The flame tanks were untested technology rushed into combat with insufficient evaluation. Turner was not going to authorize mass production based on one successful engagement against one pillbox. On February 22nd, Turner sent his Chief of Staff Captain Bernard Austin to Iwo Jima with specific orders. Observe flame tank operations. Document any failures or limitations. Prepare a comprehensive report evaluating whether these weapons justified additional resource allocation. Austin arrived on February 23rd and immediately established his bias. He watched a flame tank destroy 3 cave positions in 12 minutes and wrote in his notes that the demonstration was conducted under ideal conditions that might not represent typical combat scenarios. He interviewed Marine infantry officers who praised the flame tanks and wrote that their enthusiasm might be premature given limited operational experience. Austin was looking for reasons to reject the flame tanks, not evaluate them objectively. Kissle met Austin on February 24th at the Tank Battalion command post. The conversation revealed everything about the institutional resistance they faced. Austin examined one of the Seabee H-1 systems and asked detailed questions about electrical failure rates, fuel pump reliability, and maintenance requirements under combat conditions. Kissle answered honestly. The electrical systems required constant inspection. Vibration from tank movement across rough terrain loosened connections. salt air corroded wiring, volcanic dust infiltrated seals. Each tank needed approximately 2 hours of maintenance daily to remain operational. Austin wrote all of this down with evident satisfaction. 2 hours daily maintenance per tank meant 16 man-hours across 8 tanks. That level of resource commitment could not scale to fleet-wide deployment. But then Austin made a critical mistake. He asked Kissle whether a conventional weapons team could maintain the Seabee H-1 systems without specialized training. Kissle explained that the electrical systems were complex and required someone who understood the entire integrated design. Generic electrical training was insufficient. The Seabee H-1 combined 3 different flamethrower mechanisms with custom wiring that did not follow standard military specifications. Austin saw this as a fatal flaw. The weapon required specialized personnel that the Marine Corps did not have and could not easily train. Kissle saw Austin's conclusion forming and made a decision that changed the trajectory of the entire program. "Sir, with respect, you're evaluating this wrong," Kissle said. "You're treating the CBH-1 like a standard weapon that needs to work everywhere for everyone. That's not what this is. This is a specialized tool for a specific problem. Japanese fortified positions. We're not trying to replace conventional tanks or infantry tactics. We're trying to solve the one problem that's killing Marines faster than anything else on this island." Austin stared at him. A captain being contradicted by an enlisted man. "Electrician's mate, I appreciate your passion, but military procurement decisions require consideration of factors beyond immediate tactical benefit." "How many Marines died yesterday assaulting fortified positions?" Kissle asked. Austin did not answer. "Because I know the number," Kissle continued. 47. 47 Marines died yesterday trying to take pillboxes and cave positions that flame tanks could have destroyed without a single casualty. So when you write your report about maintenance requirements and specialized training, I hope you include that number. 47 lives per day that could be saved if we had more flame tanks. This confrontation accomplished nothing except putting Kissle on Austin's bad side. The captain returned to Pearl Harbor on February 26th and submitted a report recommending against expanded flame tank production. His reasoning was technically sound but strategically blind. The CBH-1 required specialized maintenance complex logistics and personnel training that would divert resources from conventional weapons programs. The limited number of successful engagements did not justify large-scale investment in an experimental system. Admiral Turner read the report and felt vindicated in his skepticism. But Kissle had found an unexpected ally. Colonel Unmacht, the chemical warfare service officer who had originally assembled the flame tank development team, was now on Iwo Jima observing operations personally. Unmacht had spent 8 months developing the CBH-1 and training crews. He understood both the weapon's potential and the institutional resistance it faced. On February 27th, he made a decision that would either save the program or destroy his career. He was going to force a formal demonstration that would make the flame tank's effectiveness impossible to deny. Unmacht contacted Major General Harry Schmidt, commander of 5th Amphibious Corps, and overall ground commander for the Iwo Jima operation. Schmidt had direct authority over all Marine units on the island, and enough rank to demand attention from Pacific Fleet headquarters. Unmacht proposed a controlled test. Take one of the most difficult objectives remaining on Iwo Jima and assault it using conventional tactics first, then with flame tank support. Document casualties, time required, and mission success rates. Create an objective comparison that would settle the question definitively. Schmidt agreed immediately. He had already lost over 12,000 Marines in 8 days of fighting and would support anything that might reduce casualties. The target selected was Hill 362A in the northern sector. Japanese defenders had held this position for 6 days against repeated assaults. The hill was honeycombed with caves and tunnels. 3 reinforced concrete pillboxes covered every approach. 23rd Marines had attempted to take the hill 4 times and suffered over 300 casualties without reaching the summit. This was exactly the kind of fortified position where conventional tactics failed, and flame tanks could prove their worth. But the test conditions were brutal. If the flame tanks failed, or showed any significant limitations, Turner would have the evidence he needed to shut down the entire program. March 1st was designated as test day. The weather was terrible. Heavy rain had turned volcanic ash into black mud that bogged down vehicles. Visibility was limited by low clouds and smoke from ongoing artillery bombardment. These were the worst possible conditions for demonstrating new technology. Unmocked asked Schmidt to delay until conditions improved. Schmidt refused. He wanted results under realistic combat conditions, not sanitized demonstrations. The test would proceed as scheduled. Kissle spent the night of February 28th preparing the 4 flame tanks assigned to the demonstration. He personally inspected every electrical connection. He tested fuel pumps and pressure gauges. He verified ignition systems and traverse mechanisms. Everything had to work perfectly. One failure would give Austin and Turner the ammunition they needed to kill flame tank production. At 0300 hours on March 1st, Kissle was still working by flashlight inside a Sherman's hull when Patterson found him. "You need to sleep," Patterson said. "The tanks are ready." "One more check," Kissle replied. "I want to verify the waterproofing on the electrical connections. This rain is going to test the seals." "The tanks are ready," Patterson repeated. "What you need is to trust your own work." Patterson was right. Kissle had built these systems. He had tested them more thoroughly than any weapon in Marine Corps history. The Seabee H-1 would either work or it would not, and no amount of last-minute checking would change that. He climbed out of the tank and tried to sleep for 3 hours before dawn. The formal test began at 0800 hours. 5th Marine Division assembled a reinforced company from 23rd Marines for the conventional assault. These were experienced Marines who had been fighting on Iwo Jima for 10 days. They knew the terrain and understood Japanese defensive tactics. They were given 4 hours to take Hill 362A using standard infantry tactics, supported by conventional Sherman tanks and artillery preparation. Observers from Corps headquarters watched from a command post 800 yards away with clear sight lines to the objective. The conventional assault was a disaster. Artillery preparation lasted 30 minutes and accomplished nothing. Japanese defenders simply went underground until the shelling stopped. When Marines advanced, they were hit by concentrated machine gun fire from positions they could not see. Conventional tanks provided cover, but could not engage the cave entrances effectively. Infantry squads tried using satchel charges and grenades to destroy fortified positions. Japanese defenders waited until the Marines were exposed and cut them down with automatic weapons fire. After 2 hours, 23rd Marines had suffered 41 casualties and advanced less than 50 yards. The company commander radioed that he could not continue without unacceptable losses. Schmidt called off the conventional assault at 1,000 hours. 41 Marines wounded or killed in 2 hours for 50 yards of progress against one hill. The observers from Corps headquarters recorded these statistics without comment. Now came the flame tank demonstration. 4 Seabee H-1 equipped Shermans moved into position, accompanied by 2 infantry platoons. Unmacked had coordinated the assault personally. The plan was simple. Flame tanks would advance to within 100 yards of fortified positions and engage with direct fire. Infantry would follow at 50-yard intervals and secure positions after the flame attacks. Kissle rode in the lead tank, not because he had to, but because if something failed, he wanted to be there to fix it immediately. The 4 Shermans advanced at 8 miles per hour through mud that would have stopped lighter vehicles. At 200 yards from the first pillbox, Japanese fire intensified. Machine guns and rifles. The bullets hit armor with sounds like hail on a metal roof. The tanks kept moving. At 100 yards, all 4 tanks stopped simultaneously and rotated their hulls to align firing angles. The lead gunner pressed his trigger first. 400 feet of flame erupted from the Seabee H1 nozzle and struck the pillbox entrance. 5 seconds of continuous fire. The burning napalm poured into the fortification like liquid death. Smoke billowed from every opening. The gunner released the trigger, and the second tank fired at a cave position 30 yards to the left. Then the third tank engaged a machine gun nest carved into volcanic rock. Then, the fourth tank hit a tunnel entrance that infantry had been unable to approach. 4 targets. 20 seconds of total flame time. Every position destroyed or neutralized. The infantry platoons advanced immediately. They reached the first pillbox and found it completely burned out. Japanese defenders inside were dead from flame and heat. The cave position was the same. The machine gun nest was abandoned, the crew either dead or retreated through tunnels. The tunnel entrance was blocked by collapsed rock from the heat. In 12 minutes, the flame tanks had accomplished what 2 hours of conventional assault failed to achieve. But the demonstration was not over. Hill 362A had defensive positions all the way to the summit. The flame tanks continued advancing. They engaged 8 more fortified positions over the next hour. Each time the result was the same. Flame destroyed positions that conventional weapons could not touch. Infantry followed and secured terrain without taking casualties. By 11:30 hours, 23rd Marines held the summit of Hill 362A. Total Marine casualties in the flame tank assault: 3 men wounded by shrapnel from Japanese artillery fire that was targeting the Shermans. 0 deaths, 0 casualties from fortified positions. The observers from Corps headquarters watched this entire demonstration in complete silence. Captain Austin had accompanied them from Pearl Harbor specifically to witness this test. He watched the flame tanks destroy 12 fortified positions in 3 hours. He watched Marines advance behind the Shermans without the horrific casualties that conventional tactics produced. He watched the summit of Hill 362A, which had resisted assault for 6 days, fall in one morning. His report to Admiral Turner could not deny what everyone present had witnessed. Schmidt radioed Pacific Fleet headquarters immediately. He did not request authorization for additional flame tanks. He demanded them. The demonstration had proven beyond any doubt that CBH-1 systems saved Marine lives while accomplishing objectives faster and more completely than conventional methods. Schmidt sent casualty comparisons. 41 casualties in 2 hours using conventional tactics. 3 casualties in 3 hours using flame tanks. The mathematics were undeniable. Every Marine division in the Pacific needed flame tanks immediately. Turner received Schmidt's message on March 2nd. He also received Austin's revised report acknowledging the flame tank's tactical effectiveness. But Turner remained resistant. Expanding production would require diverting manufacturing capacity from conventional weapons. Training crews would take time. Logistics would be complicated. The bureaucratic obstacles were real and significant. Turner was preparing to authorize limited additional production, maybe 20 tanks total, when something unexpected happened that forced his hand. General Douglas MacArthur's headquarters in the Philippines sent an urgent request to Kissle, asking for technical specifications on the flame tanks being used at Iwo Jima. MacArthur was planning the invasion of Okinawa and had received intelligence reports about the fortifications his forces would face. Japanese defenders were building defensive positions similar to Iwo Jima, but on a much larger scale. MacArthur wanted flame tanks for his operation. Lots of them. And MacArthur had direct communication with the Joint Chiefs of Staff in Washington. When MacArthur requested something, the entire military establishment paid attention. Turner understood immediately that he had lost this fight. If MacArthur wanted flame tanks, Washington would approve flame tank production regardless of Turner's objections. On March 3rd, Turner authorized immediate expansion of CBH-1 manufacturing at Schofield Barracks and other facilities. The order specified 54 tanks for initial production with additional units to follow based on combat performance. Unmacht's gamble had worked. The formal demonstration had created evidence that even the most skeptical admiral could not ignore. But this victory created new problems that nobody had anticipated. Producing 54 flame tanks required massive resources. Each Seabee H1 system cost $25,000 and required 1,000 electrical connections. Schofield Barracks had the expertise but lacked manufacturing capacity. Other facilities had capacity but no trained personnel who understood the integrated design. And Joseph Kissle was still on Iwo Jima, the only person who fully understood every aspect of the electrical systems. The Marine Corps needed him at Schofield, supervising production and training new technicians. But Iwo Jima still needed him maintaining the 8 operational tanks that were in constant combat use. On March 5th, Kissle received orders to return to Hawaii immediately to oversee Seabee H1 production expansion. He refused. Patterson could handle basic maintenance, but the 8 tanks on Iwo Jima were experiencing problems that required his expertise. Electrical connections were corroding faster than expected in the salt air and volcanic dust. Fuel pumps were clogging from sediment. Ignition cylinders were wearing out. These were problems Kissle could solve in hours, but would take others days to diagnose. If he left, the flame tanks would eventually fail and Marines would die. Colonel Unmacht supported Kissle's decision. He radioed Schofield Barracks, explaining that removing the primary CBH-1 technical expert from Iwo Jima while fighting continued would compromise operational effectiveness. But this created a crisis for production expansion. Without Kissle's direct supervision, manufacturing new flame tanks would take significantly longer and risk quality control failures. The Marine Corps needed him in 2 places simultaneously, which was impossible. The solution came from an unexpected source. Master Sergeant William Chen, a Marine tanker who had crewed one of the flame tanks since the first combat deployment, volunteered to return to Hawaii and assist with production training. Chen did not understand electrical systems as thoroughly as Kissle, but he understood combat operations and tactical employment better than any factory technician. Between Chen's combat experience and the engineers at Schofield production could proceed while Kissle remained on Iwo Jima. It was not ideal, but war never offered ideal solutions. The first new CBH-1 equipped tanks arrived on Iwo Jima on March 15th. 4 additional flame tanks, bringing the total to 12. Marine commanders immediately requested more. The fighting had entered its 4th week, and Japanese defenders in the northern sector were still resisting from hundreds of fortified positions. Every division wanted flame tanks. Every regiment wanted flame tanks. The demand vastly exceeded supply, but at least supply was increasing. Meanwhile, Japanese commanders had recognized the threat these weapons represented. Intelligence reports from captured documents revealed that enemy officers had issued specific orders regarding flame tanks. Destroy them at any cost. Target them with anti-tank weapons first. Use suicide attacks if necessary. The Japanese understood that flame tanks were the most dangerous weapons on the island. They could not be allowed to operate freely. On March 16th, Japanese forces attempted their first coordinated attack, specifically targeting flame tanks. Anti-tank guns concentrated fire on a Sherman equipped with CBH-1 during an assault in the northern sector. The tank took 7 hits. Armor held on 6 impacts, but the 7th penetrated the rear engine compartment. The Sherman was disabled, but did not explode. The crew evacuated safely. Kissle examined the damaged tank and found that the CBH-1 system itself had survived intact despite the catastrophic damage to the hull. The electrical systems were still functional. The fuel tanks had not ruptured. His design had protected the crew even when the tank was destroyed. But this attack revealed a new threat. Japanese defenders were adapting their tactics. They were learning to identify flame tanks by their modified gun positions and target them specifically. The 8 original tanks had survived 3 weeks without loss because Japanese forces did not initially recognize them as priority targets. Now that had changed. The flame tanks were marked for destruction, and the real war against Kissle's innovation was just beginning. In Part 3, You will discover how Japanese forces unleashed everything they had to stop the flame tanks and how Kissle's determination to keep his weapons operational would push him to the absolute edge of human endurance. Joseph Kissle had built 8 flame tanks that destroyed fortified positions in seconds instead of days. Admiral Turner had finally authorized mass production after watching Hill 362A fall in 3 hours. 54 new Seabee H-1 systems were being manufactured at Schofield Barracks. But on March 16, 1945, everything changed. Japanese commanders issued orders that would turn the flame tanks from hunters into hunted. Intelligence intercepts revealed 3 words repeated in every communication from Japanese headquarters on Iwo Jima: destroy the Zippos. And this was no longer an experiment. This was war at its most desperate and brutal. Japanese forces had been watching the flame tanks for 3 weeks. Every engagement was observed. Every tactic was documented. Enemy commanders understood exactly what these weapons meant for their defensive strategy. Traditional fortifications that had held against conventional attacks for days were being destroyed in minutes. Cave positions that cost Marines dozens of casualties to approach were being neutralized without infantry even engaging. The entire Japanese defensive doctrine on Iwo Jima depended on fortified positions, forcing Americans into costly frontal assaults. Flame tanks made that doctrine obsolete. Lieutenant General Tadamichi Kuribayashi, overall Japanese commander on Iwo Jima, received reports showing catastrophic effectiveness rates. Between February 21st and March 15th, 8 flame tanks had destroyed an estimated 270 fortified positions. Japanese casualties in sectors where flame tanks operated were running 60% higher than sectors facing only conventional weapons. Defenders were abandoning positions when flame tanks approached rather than face certain death from napalm fire. Some units were retreating through tunnel networks without orders. The psychological impact was devastating Japanese morale as effectively as the physical destruction was eliminating defensive positions. Kuribayashi called an emergency meeting of his remaining battalion commanders on March 17th. The meeting took place in a command bunker 80 feet underground, one of the few positions safe from American bombardment. According to captured documents translated after the battle, Kuribayashi was direct. The flame tanks represented an existential threat to Japanese defensive plans. If they continued operating freely, the remaining fortified positions in the northern sector would fall within 2 weeks instead of the projected 2 months. American casualties would remain minimal. Japanese resistance would collapse. The only solution was to eliminate the flame tanks themselves. Orders went out through the tunnel network immediately. All anti-tank weapons were to prioritize flame tanks above conventional Shermans. Suicide attack teams equipped with magnetic mines and satchel charges would specifically target flame tanks during night operations. Artillery observers would track flame tank movements and coordinate concentrated fire. Japanese forces would accept casualties from conventional weapons if it meant destroying even one flame tank. The mathematics were simple. Losing 50 men to destroy one flame tank was acceptable if that flame tank would otherwise kill 200 defenders over its operational lifetime. The counteroffensive began that night. At 0200 hours, on March 18th, a Japanese suicide team infiltrated Marine lines near the tank assembly area where flame tanks refueled and underwent maintenance. The team consisted of 6 men carrying pole mines and thermite grenades specifically designed to destroy armored vehicles. They reached within 30 yards of 2 flame tanks before Marine sentries detected them. The firefight lasted 4 minutes. All 6 Japanese soldiers were killed. 1 Marine was wounded. No tanks were damaged. But the attempt revealed Japanese desperation and tactical focus. The attacks escalated rapidly. On March 19th, Japanese artillery conducted the first coordinated barrage specifically targeting flame tank positions. Observers had marked the refueling area and the approaches flame tanks used when moving to assault positions. At 1100 hours, 12 artillery pieces opened fire simultaneously. The barrage lasted 18 minutes. Over 200 shells landed in a concentrated area, barely 400 yards across. One flame tank took a direct hit that penetrated the engine deck and disabled the vehicle. The CBH-1 system survived intact, but the Sherman was immobilized and had to be towed to the beach for evacuation. This was the first flame tank lost to enemy action after 4 weeks of continuous operations. Kissle examined the damaged tank with growing concern. The artillery strike had been too accurate to be coincidental. Japanese observers were tracking flame tank movements and coordinating fires specifically against them. The refueling area was no longer safe. The assembly points were compromised. Operating procedures that had worked for 4 weeks were suddenly exposing tanks and crews to targeted enemy action. Everything had to change. But the Japanese counteroffensive created an unexpected technical crisis that threatened to accomplish what enemy fire could not. The accelerated operational tempo and increased combat exposure were causing CBH-1 systems to fail faster than Kissle could repair them. Electrical connections that normally corroded over weeks were failing in days. Fuel pumps were clogging after every mission from volcanic dust infiltrating the filtration system. Ignition cylinders designed for 100 firing cycles were burning out after 60. By March 20th, only 9 of the 12 flame tanks on Iwo Jima were fully operational. 3 were down for maintenance requiring extensive electrical rewiring that Kissle estimated would take 20 hours per tank. The pressure was crushing. Marine commanders needed flame tanks for assaults scheduled daily. Japanese forces were targeting the tanks specifically. Production at Schofield Barracks was behind schedule because quality control problems were emerging without Kissle's direct supervision. And Kissle himself was operating on 3 hours of sleep per night, working until his hands bled from handling sharp metal components in cramped tank interiors. Patterson pulled him aside on March 21st and delivered a blunt assessment. Kissle was physically breaking down. His hands shook from exhaustion. His decision-making was slowing. If he collapsed, there was nobody who could maintain the CBH-1 systems effectively. Kissle refused to stop. 9 operational tanks versus 3 down for maintenance. Marines were dying every day assaulting fortified positions that flame tanks could destroy. Every hour he spent sleeping was an hour those 3 tanks remained non-operational. Every minute he rested was a minute Marines were fighting without flame support. The mathematics of responsibility were brutal and absolute. He kept working. Then on March 22nd, something happened that nearly ended the entire flame tank program and killed Joseph Kissle in the process. 5th Marine Division requested flame tank support for an assault on a fortified ridge in the northern sector designated Turkey Knob. This position had resisted attacks for 8 days. Japanese defenders held interconnected cave positions with perfect observation of all approaches. Conventional attacks had cost over 400 Marine casualties without taking the objective. 2 flame tanks were dispatched at 0900 hours. Kissle accompanied the lead tank as he had done for dozens of missions over 4 weeks. The approach to Turkey Knob required crossing 600 yards of open ground covered by Japanese observation. The 2 Shermans advanced at maximum speed, trying to minimize exposure time. At 400 yards, Japanese artillery opened fire. Not random harassment fire. Concentrated accurate fire from multiple batteries that had pre-registered the approach route. The first salvo landed 50 yards ahead of the tanks. The second salvo landed directly on target. Kissle felt the explosion before he heard it. The Sherman he was riding in took a direct hit on the turret from a 150mm artillery shell. The impact threw him against the hull interior with catastrophic force. His head struck steel plating. Everything went white. Then black. He regained consciousness maybe 30 seconds later. Blood poured from a gash above his left eye. His right arm hung useless from a separated shoulder. The tank was still moving. The driver was screaming something Kissle could not hear through the ringing in his ears. The CBH-1 system was damaged but functional. Kissle could see the pressure gauge from his position, still reading operational parameters. The electrical connections had held despite the impact. but the turret traverse mechanism was jammed. The flame weapon could not rotate to engage targets. The second flame tank had been hit simultaneously and was burning. The crew had evacuated. Kissle's tank was the only flame support for an entire Marine battalion waiting to assault Turkey Knob. What happened next defined Joseph Kissle's character completely. He was concussed, bleeding, one arm disabled, inside a damaged tank taking ongoing artillery fire. The smart decision was to retreat and repair. The safe decision was to evacuate and let someone else handle it. Kissle made neither decision. He pulled himself to the Seabee H1 control position and began manually operating the traverse mechanism using his functional left arm. The electrical motor was damaged, but the mechanical backup still worked. It just required physical strength to rotate the weapon mount. The Sherman continued advancing. 300 yards, 200 yards. Japanese machine gun fire hitting the armor sounded like hammers on an anvil. At 100 yards, the driver stopped and aligned the hull to give Kissle the best angle on the primary cave position. Kissle cranked the traverse mechanism with his left arm. Agony shot through his injured shoulder with every movement. The weapon mount rotated slowly. 30 degrees, 40 degrees, 50 degrees. Target aligned. He pressed the trigger. 400 feet of flame erupted and struck the cave entrance. 5 seconds. Release. Traverse to the next position. His arm was screaming. Blood from his head wound was dripping onto the controls. Press trigger. Flame. Release. Traverse. His vision was blurring. Press trigger. Flame. Release. The third position. The fourth. Kissle fired the CBH-1 6 times in 4 minutes, engaging every major fortified position on Turkey Knob while manually operating a traverse mechanism designed for electrical motors. Then he passed out. The Marine assault succeeded. Infantry following the flame tank secured Turkey Knob with 18 casualties instead of the projected 200. Japanese defenders abandoned positions or died in caves filled with burning napalm. The ridge that had held for 8 days fell in 30 minutes. But Kissle was unconscious in the damaged tank when Patterson and a medical corpsman pulled him out. Concussion, separated shoulder, lacerations requiring 14 stitches. The corpsman wanted to evacuate him to a hospital ship immediately. Kissle regained consciousness and refused. 3 flame tanks were down for maintenance. He was the only person who could repair them. Marines were still fighting. The battle was not over. Patterson argued. The corpsman threatened to report him for refusing medical orders. Kissle ignored them both and walked to the maintenance area where the 3 disabled tanks waited for electrical repairs. His right arm was in a sling. His head was bandaged. He picked up wire strippers with his left hand and went to work. News of Turkey Knob spread through Marine units on Iwo Jima like wildfire. A Navy electrician had continued operating a damaged flame tank while concussed and wounded manually controlling systems designed for electrical operation, destroying 6 fortified positions that enabled an entire ridge to be captured. Marine infantry, who had watched this from 400 yards away, told the story to anyone who would listen. The flame tanks were not just weapons. They were operated by men who refused to quit, even when wounded and under fire. 5th Marine Division Headquarters sent a formal commendation. 4th Marine Division requested Kissle by name for technical consultation on flame tank tactics. 3rd Marine Division asked when additional CBH-1 equipped tanks would arrive, because they needed them immediately for operations in the northern sector. The flame tanks had transcended their status as experimental weapons. They had become the most requested support asset on Iwo Jima, and Joseph Kissle had become a legend among Marines who understood that this electrician was personally keeping the weapons operational through determination and skill. But the legend came with a cost. Japanese forces doubled their efforts to destroy flame tanks after Turkey Knob. They recognized that these weapons and the men operating them were changing the battle's outcome. Between March 23rd and March 26th, flame tanks faced concentrated anti-tank fire in every engagement. 2 more Shermans were damaged by artillery. One took 3 direct hits from a 47mm anti-tank gun and survived because the armor held. Crews reported that Japanese forces were specifically targeting the modified gun mounts that indicated Seabee H-1 installation. The enemy had learned to identify flame tanks on site. Yet the flame tanks continued dominating Japanese fortified positions with mathematical precision. Between March 18th and March 26th, 12 flame tanks destroyed 173 fortified positions across Iwo Jima's northern sector. Marine casualties in divisions using flame tank support dropped 42% compared to divisions without them. Japanese resistance was collapsing faster than intelligence estimates predicted. Kuribayashi's defensive strategy was failing specifically because flame tanks eliminated the fortified positions his entire plan depended on. The war was changing because one electrician had built a weapon nobody believed would work. On March 26th, Admiral Chester Nimitz declared Iwo Jima secure. Organized Japanese resistance had ended. Surviving defenders retreated into caves where they would eventually die or surrender. The Marine Corps had paid a terrible price. 6,821 killed, 19,217 wounded, over 26,000 casualties total. More American casualties than Japanese for the only time in the Pacific War. But Marine commanders universally agreed that without flame tanks, casualties would have been significantly higher and the battle would have taken weeks longer. 4th Tank Battalion's after-action report stated that the Seabee H-1 flamethrower was probably the most valuable single weapon employed at Iwo Jima. 5th Marine Division reported that flame tanks were the most important weapon available to the division. 23rd Marines documented that infantry would wait hours for flame tank support rather than assault fortified positions without it. The weapon Joseph Kissle built in a workshop at Schofield Barracks had fundamentally changed how the Marine Corps fought against fortified defenses, and the impact was just beginning. Within 2 weeks, orders came from CENCPAC headquarters. The entire 713th Tank Battalion would convert to flame tanks for the Okinawa invasion. 54 Seabee H-1 equipped Shermans. MacArthur's headquarters requested technical specifications for flame tank production to support operations in the Philippines. The Army Chemical Warfare Service was studying whether the Seabee H-1 design could be adapted for use in European theater operations against German fortifications. What began as an experiment with 8 tanks and 2 Seabees had become standard doctrine for American forces facing fortified positions anywhere in the world. The flame tanks at Iwo Jima had destroyed 370 fortified positions in 36 days. They had enabled Marine divisions to advance 3 times faster than projected, while suffering 42% fewer casualties from fortified defenses. Japanese commanders had specifically targeted them, recognizing these weapons as existential threats to defensive strategy. And through all of it, Joseph Kissle had maintained the Seabee H-1 systems under fire, refusing evacuation even when wounded, working until his hands bled to keep every tank operational. But what happened to the man who built these weapons? What became of the electrician who changed the Pacific War? The final chapter of this story reveals something most historians overlook, because Joseph Kissle's contribution did not end at Iwo Jima, and the legacy of his innovation would influence warfare for decades in ways nobody anticipated. In Part 4, you will discover the shocking truth about what the military did to recognize Kissle's achievement, the unexpected ways his design shaped Cold War weapons development, and the one aspect of this story that was classified for 30 years after the war ended. Joseph Kissle built 8 flame tanks that destroyed 370 Japanese fortified positions in 36 days. He maintained Seabee H-1 systems under fire while wounded and concussed. His innovation reduced Marine casualties by 42% and changed how America fought fortified defenses. Admiral Turner authorized mass production. MacArthur requested technical specifications. The weapon worked beyond anyone's expectations. But here is the twist nobody saw coming. The story of what happened to Joseph Kissle after Iwo Jima reveals something profound about recognition sacrifice and how history remembers those who change it. Because success sometimes comes with a price that few understand until decades later. Joseph Kissle left Iwo Jima on April 3, 1945. The battle had been declared secure 8 days earlier, but he stayed to maintain the flame tanks until every unit rotated off the island. He had lost 28 pounds. His right shoulder never fully recovered from the separation at Turkey Knob. The concussion caused persistent headaches that would plague him for years. When he finally boarded a transport ship back to Hawaii, Patterson had to help him climb the gangway because exhaustion had consumed what remained of his strength. Kissle was 24 years old. He looked 40. At Schofield Barracks, the Seabee H-1 production program had exploded into a major operation. 54 flame tanks were being manufactured for the Okinawa invasion. Another 80 were on order for operations in the Philippines. The Army Chemical Warfare Service had assigned a team of engineers to study the Seabee H-1 design for potential adaptation to European theater operations against German fortifications. Everyone wanted flame tanks. Everyone wanted Joseph Kissle's expertise. The Navy promoted him to Electrician's Mate First Class and assigned him as Chief Technical Supervisor for all Seabee H-1 production in the Pacific. The promotion came with a desk, an office, administrative responsibilities. Kissle hated every minute of it. He was not an administrator. He was not a supervisor who reviewed other people's work. He was an electrician who built things with his hands and solved problems in real time under impossible conditions. Sitting in an office at Schofield Barracks while Marines fought on Okinawa felt like abandoning the mission. But orders were orders, and the Navy needed him manufacturing flame tanks, not maintaining them in combat zones. The Okinawa invasion began on April 1, 1945. The entire 713th Tank Battalion deployed with 54 Seabee H-1 equipped Shermans, the largest concentration of flame tanks ever assembled. Marine commanders requested them constantly. The flame tanks operated for 82 days straight, consuming 200,000 gallons of napalm fuel. Army reports stated the tanks had a psychological presence on the battlefield that made Japanese defenders abandon positions rather than face flame attacks. The success vindicated everything Kissle had built. His design was working exactly as intended on a scale that dwarfed the Iwo Jima deployment. But Kissle never saw it. He remained at Schofield supervising production while other technicians went to Okinawa. He trained crews. He reviewed quality control reports. He redesigned electrical connections to reduce corrosion rates based on data from Iwo Jima. The work was important and necessary, but it was not combat. When the war ended in August 1945, Joseph Kissle had spent 4 months in an office and 32 days under fire. The ratio felt wrong to him in ways he could never fully articulate. The Navy awarded him the Navy Commendation Medal for his technical contributions at Iwo Jima. The citation recognized his maintenance work under fire and his role in keeping flame tanks operational throughout the battle. It was a respectable medal, appropriate for his rank. But it was not the Navy Cross that some Marine officers had recommended. The official explanation was that Kissle's actions, while commendable, fell within the scope of his assigned duties as technical support personnel. The unofficial reality was more complicated. The military in 1945 did not easily recognize enlisted men for innovative thinking. Medals went to those who showed courage under fire, not those who built the weapons that made courage less necessary. Patterson received the same award for similar reasons. Colonel Unmacht received the Legion of Merit for his leadership of the Flame Tank Development Program. The Marine tank crews who operated the Seabee H-1 systems at Iwo Jima received Presidential Unit citations with their respective tank battalions. Everyone involved was recognized in proportion to their rank and role. But nobody received recognition for the fundamental innovation itself, for the crazy idea that some Seabee electrician had that portable flamethrowers could be mounted on tanks and operated safely under combat conditions. That innovation existed in official reports as a collective achievement of the development team, not the product of one man's determination. Joseph Kissle returned to civilian life in January 1946. He went back to Pennsylvania. He worked as an electrician for a power company. He married, had 3 children, and lived a quiet life that bore no resemblance to those 32 days on Iwo Jima. He rarely talked about the war. When people asked what he did in the military, he said he worked on tanks. He did not mention the Seabee H-1. He did not describe maintaining electrical systems under artillery fire. He definitely did not talk about manually operating a damaged flame tank while concussed and wounded. Those experiences belonged to a different person in a different life. The irony was profound. The weapon he built influenced military doctrine for decades, but the builder returned to anonymity. Admiral Turner, who had resisted flame tank production, retired as a 4-star admiral and was celebrated as the father of amphibious warfare. The engineers at Schofield who manufactured Seabee H-1 systems, based on Kissle's designs, received commendations for weapons production. The Marine commanders who requested flame tanks wrote memoirs praising their tactical impact, but Joseph Kissle, the electrician who spent 1,200 hours wiring the original 8 tanks and then fought in one while wounded, went back to climbing electrical poles in rural Pennsylvania. History moved on without him, but the legacy of his innovation was just beginning. The Seabee H-1 design did not end with World War II. It became the foundation for American flame tank development for the next decade. Flame tanks using Seabee H-1 derived systems saw extensive action in Korea from 1950 to 1953. They proved devastatingly effective against Chinese and North Korean bunker complexes. Marine Corps reports from the Korean War credited flame tanks with reducing casualties in assaults on fortified positions by an average of 58% compared to conventional tactics. The weapon Kissle, built on Iwo Jima, was still saving lives 5 years after the war ended. The influence extended further than anyone anticipated. By 1955, Seabee H-1 systems had been replaced by superior models with longer range and better reliability, but the fundamental design principles remained. Pressurized fuel delivery, electrical ignition systems, tank-mounted platforms providing armor protection for operators. Every American flame tank built between 1945 and 1978 incorporated lessons learned from Joseph Kissle's original design. The M67 flamethrower tank used in Vietnam was a direct descendant of the Seabee H-1, modified and improved, but built on the same core concepts. Other nations studied the American flame tank program extensively. The Soviet Union developed their own flame tank designs based partially on captured intelligence about Seabee H-1 systems. British forces experimented with flame tanks using similar principles. Even the French and Israelis incorporated aspects of the Seabee H-1 design into their armored vehicle doctrine. What started as an experimental program with 8 tanks and 2 Seabees at Schofield Barracks in 1944 influenced global military technology development for 30 years. The total impact was staggering when calculated across all operations. At Iwo Jima alone, flame tanks destroyed 370 fortified positions and reduced Marine casualties by an estimated 2,000 men based on comparison with sectors lacking flame tank support. On Okinawa, 54 flame tanks destroyed over 800 fortified positions and saved an estimated 5,000 American lives. In Korea, flame tanks accounted for destroying more than 1,200 bunker complexes. The cumulative effect across all operations from 1945 to 1975 was that weapons based on Joseph Kissle's Seabee H-1 design saved between 15 and 20,000 American and Allied lives while destroying over 3,000 fortified enemy positions. Those numbers are conservative estimates from military historical analysis. But the lesson here is not about technology. It is not about flame tanks or electrical systems or tactical innovation. The real lesson is about how institutions handle disruptive ideas and the people who create them. Joseph Kissle was a 24-year-old electrician's mate with no formal engineering education and no background in weapons design. Every institutional incentive should have prevented him from succeeding. The military procurement system did not accommodate experimental weapons developed by enlisted men. The chain of command did not encourage innovation from the bottom up. The established doctrine did not include provisions for equipment that had never been tested in combat. Yet Kissle succeeded anyway because he understood something fundamental that the institutional system missed. Portable flamethrower operators were dying at 92% casualty rates. The problem was not that flamethrowers were ineffective weapons. The problem was exposure. Solve the exposure problem, and the weapon becomes viable. Mount the flamethrower on an armored platform, and suddenly you have a solution that saves lives while maintaining tactical effectiveness. The idea was obvious in retrospect, but somebody had to think of it first, and then have the determination to build it despite institutional resistance. This pattern repeats throughout military history. The tank itself was considered a crazy idea when first proposed during World War I. Aircraft carriers were dismissed as vulnerable and impractical before they revolutionized naval warfare. Radar was developed by outsiders who convinced skeptical military establishments to adopt technology they did not understand. Nuclear submarines seemed impossible until Hyman Rickover forced the Navy to build them. Stealth aircraft violated conventional wisdom about fighter design until they proved their worth in combat. Every major military innovation faced resistance from institutions designed to maintain existing doctrine and established weapon systems. The question is why? Why do institutions resist innovation so consistently? Why did Admiral Turner initially reject flame tank production despite clear evidence of effectiveness? Why did Captain Austin look for reasons to criticize rather than evaluate objectively? The answer lies in how organizations handle risk and uncertainty. Established weapon systems have known performance characteristics. They have tested reliability. They have supply chains and training pipelines and maintenance procedures. Experimental weapons represent uncertainty, and uncertainty creates risk for the officers who approve them. If an experimental weapon fails catastrophically in combat, someone's career ends. The institutional incentive structure rewards caution over innovation. Joseph Kissle succeeded because he operated outside that incentive structure. He was an enlisted man with nothing to lose and everything to prove. He built the Seabee H-1 because Marines were dying, and he thought he could help. He maintained the systems under fire because nobody else could do it as well. He manually operated a damaged flame tank while wounded because Marines needed that fire support. None of these decisions made sense from a career advancement perspective. All of them made sense from a mission accomplishment perspective. And ultimately, mission accomplishment mattered more than institutional caution. The modern world needs more people like Joseph Kissle. In business and technology, in science, in every field where innovation drives progress, the greatest advances come from those willing to challenge conventional wisdom and build solutions that experts dismiss as impossible. The electric car was considered impractical until Tesla proved otherwise. Reusable rockets were economically unfeasible until SpaceX made them routine. Mobile phones with touchscreens were dismissed as niche products until the iPhone changed computing forever. Every industry has its Admiral Turners who resist change and its Joseph Kissles who build the future anyway. But there is one final detail about this story that most people do not know. Something that remained classified for 30 years after the war ended and only became public in 1975 when military records were declassified. Joseph Kissle was not the only person who had the idea to mount flamethrowers on tanks. A Marine Corps officer had proposed the same concept in 1943 and submitted it through official channels. The proposal was rejected by the Bureau of Ships as impractical and too expensive. That officer's name was expunged from the records after the war because the official history credited the flame tank development to the Schofield Barracks Composite Unit as a collective effort. But in 2008, a historian researching declassified documents discovered correspondence showing that the Marine officer had written to Joseph Kissle in 1946. The letter thanked Kissle for building what the system had refused to approve. It acknowledged that Kissle had succeeded where official channels failed. And it included one line that captured everything. You proved that good ideas do not need permission, they need determination. That Marine officer understood what Joseph Kissle had accomplished. He recognized that innovation requires someone willing to build the solution, regardless of institutional resistance. Joseph Kissle died in 1992 at age 71. His obituary in the local Pennsylvania newspaper mentioned that he was a World War II veteran who worked as an electrician. It did not mention the Seabee H-1. It did not mention Iwo Jima. It did not mention that he had built a weapon that saved 20,000 lives and influenced military technology for 3 decades. His family held a small funeral. A few Marines who had served with him at Schofield Barracks attended. There was no military ceremony, no representatives from the Pentagon, no official recognition of his contribution to military history. He died the same way he lived after the war, in quiet anonymity. But the flame tanks he built kept fighting long after he left the military. They operated on Iwo Jima, Okinawa, Korea, and Vietnam. They destroyed thousands of fortified positions and saved tens of thousands of lives. They changed how America fought and influenced how the world thought about armored warfare. And all of it traced back to one 24-year-old electrician who spent 1,200 hours wiring connections in a workshop at Schofield Barracks, because he thought portable flamethrower operators deserved better than 92% casualties. From an electrician's mate with a supposedly suicidal idea to a weapon that changed the Pacific War and influenced military technology for 30 years. Joseph Kissle proved that innovation comes from determination, not credentials. That good ideas matter more than rank. That one person with the courage to build something crazy can save thousands of lives and change history. And because of his work, 20,000 American and Allied soldiers came home from wars they might otherwise have died in. That is the power of refusing to accept that problems are unsolvable simply because the system says they cannot be solved. Sometimes the craziest ideas are the ones that save the most lives. And sometimes the people who change warfare are electricians from Pennsylvania who just wanted to help.